All right, this is CS50, and this is already week 6, and this is the week in which you learn yet another language. But the goal is not just to teach you another language for language's sake. As we transition today and in the coming weeks from C, where we've spent the past several weeks, now to Python, the goal ultimately is to teach you all how to teach yourselves new languages, so that by the end of this course, it's not in your mind the fact that you learned how to program in C or learned some weeks back how to program in Scratch, but really how you learned how to program fundamentally in a paradigm known as procedural programming, as well as with some taste today and in the weeks to come of other aspects of programming languages like object-oriented programming and more. So recall, though, back in week 0, Hello World looked a little something like this, and the world was quite simple. All you had to do was drag and drop these puzzle pieces, but there were still functions and conditionals and loops and variables and all of those kinds of primitives. We then transitioned, of course, to a much more arcane language that looked a little something like this. And even now, some weeks later, you might still be struggling with some of the syntax or getting annoying bugs when you try to compile your code and it just doesn't work. But there too, the past few weeks, we've been focusing on functions and loops and variables, conditionals, and really all of those same ideas. And so what we begin to do today is to, one, simplify the language we're using, transitioning from C now to Python, this now being the equivalent program in Python and look at its relative simplicity, but also transitioning to look at how you can implement these same kinds of features just using a different language. So we're going to see a lot of code today, and you won't have nearly as much practice with Python as you did with C, but that's because so many of the ideas are still going to be with us. And really, it's going to be a process of figuring out, all right, I want to do a loop. I know how to do it in C. How do I do this in Python? How do I do the same with conditionals? How do I declare variables and the like? And moving forward, not just in CS50, but in life in general, if you continue programming and learn some other language after the class, if in 5, 10 years there's a new, more popular language that you pick up, it's just going to be a matter of Googling and looking at websites like Stack Overflow and the like to look at just basic building blocks of programming languages, because you already speak, after these past 6+ weeks, you already speak programming itself fundamentally. All right, so let's do a few quick comparisons left and right of what something might have looked like in Scratch and what it then looked like in C, but now as of today, what it's going to look like in Python. Then we'll turn our attention to the command line ultimately in order to implement some actual programs. So in Scratch, we had functions like this, say hello world, a verb or an action. In C, it looked a little something like this, and a bit of a cryptic mess the first week. You had the printf, you had the double quotes, you had the semicolon, the parentheses. So there was a lot more syntax just to do the same thing. We're not going to get rid of all of that syntax now, but as of today in Python, that same statement is going to look a little something like this. And just to perhaps call out the obvious, what is different or now simpler in Python versus C, even in this simple example here? Yeah? Good. So it's now print instead of printf, and there's also no semicolon, and there's one other subtlety over here. Yeah, so no new line. And that doesn't mean it's not going to be printed. It just turns out that one of the differences we'll see is that with print, you get the new line for free. It automatically gets outputted by default, being sort of a common case, but you can override it, we'll see ultimately too. How about in Scratch? We had multiple functions like this that not only said something on the screen, but also asked a question, thereby being another function that returned a value called answer. In C, we saw code that looked a little something like this, whereby that first line declares a variable called answer, sets it equal to the return value of getString, one of the functions from the CS50 library, and then the same double quotes and parentheses and semicolon. Then we had this format code in C that allowed us with %s to actually print out that same value. In Python, this too is going to look a little bit simpler. Instead, we're going to have answer equals getString, quote unquote, what's your name, and then print with a plus sign and a little bit of new syntax. But let's see if we can't just infer from this example what it is that's going on. Well, first, missing on the left is what? To the left of the equal sign, there's no what this time. Feel free to just call it out. So there's no type. There's no type like the word string, which even though that was a type in CS50, every other variable in C did we use int or string or float or bool or something else. In Python, there's still going to be data types today onward, but you, the programmer, don't have to bother telling the computer what types you're using. The computer is going to be smart enough, the language really is going to be smart enough to just figure it out from context. Meanwhile, on the right-hand side, getString is going to be a function we'll use today and this week, which comes from a Python version of the CS50 library, but we'll also start to take off those training wheels so that you'll see how to do things without any CS50 library moving forward, using a different function instead. As before, no semicolon, but the rest of the syntax is pretty much the same here. This starts, of course, to get a little bit different, though. We're using print instead of printf. But now, even though this looks a little cryptic perhaps if you've never programmed before CS50, what might that plus be doing? Just based on inference here. What do you think? Yeah, so adding answer to the string hello, and adding, so to speak, not mathematically, but in the form of joining them together, much like we saw the join block in Scratch, or concatenation was the term of art there. This plus sign appends, if you will, whatever's in answer to whatever is quoted here. And I deliberately left a space there so that grammatically it looks nice after the comma as well. Now, there's another way to do this, and it too is going to look cryptic at first glance, but it just gets easier and more convenient over time. You can also change this second line to be this instead. So what's going on here? This is actually a relatively new feature of Python in the past couple of years, where now what you're seeing is, yes, a string between these same double quotes, but this is what Python would call a format string, or F string. And it literally starts with the letter F, which admittedly looks, I think, a little weird. But that just indicates that Python should assume that anything inside of curly braces inside of the string should be interpolated, so to speak, which is a fancy term saying substitute the value of any variables therein. And it can do some other things as well. So answer is a variable, declared, of course, on this first line. This F string then says to Python, print out hello, comma, space, and then the value of answer. If, by contrast, if you omitted the curly braces, just take a guess. What would happen? What would the symptom of that bug be if you accidentally forgot the curly braces, but maybe still had the F there? Yeah, it would literally print hello, comma, answer, because it's going to take you literally. So the curly braces just kind of allow you to plug things in. And again, it looks a little more cryptic, but it's just going to save us time over time. And if any of you programmed in Java in high school, for instance, you saw plus in that context too for concatenation. This just kind of makes your code a little tighter, a little more succinct. So it's a convenient feature now in Python. All right, this was an example in Scratch of a variable, setting a variable like counter equal to 0. In C, it looked like this, where you specify the type, the name, and then the value with a semicolon. In Python, it's going to look like this. And I'll state the obvious here. You don't need to mention the type, just like before with string. And you don't need a semicolon. So it's a little simpler. If you want a variable, just write it and set it equal to some value. But the single equal sign still behaves the same as in C. Suppose we wanted to increment counter by 1. In Scratch, we use this puzzle piece here. In C, we could do this actually in a few different ways. There was this way. If counter already exists, you just say counter equals counter plus 1. There was the slightly less verbose way where you could say, whoops, sorry. Let me do the first sentence first. In Python, that same thing, as you might guess, is actually going to be almost the same. You just throw away the semicolon. And the mathematics are ultimately the same, copying from right to left via the assignment operator. Now recall in C that we had this shorthand notation, which did the same thing. In Python, you can similarly do the same thing, just no need for the semicolon. The only step backwards we're taking, if you were a big fan of counter plus plus, that doesn't exist in Python, nor minus minus. You just can't do it. You have to do the plus equals 1 or plus minus or minus equals 1 to achieve that same result. All right, how about in Python 2? Here in Scratch, recall, was a conditional, asking a silly question like, is x less than y? And if so, just say as much. In C, that looked a little something like this, printf and if with the parentheses, the curly braces, the semicolon, and all of that. In Python, this is going to get a little more pleasant to type too. It's going to be just this. And if someone wants to call out some of the obvious changes here, what has been simplified now in Python for a conditional, it would seem? Yeah, what's missing or changed? So no curly braces. And sorry? And we're using the colon instead. So I got rid of the curly braces in Python, but I'm using a colon instead. And even though this is a single line of code, so long as you indent subsequent lines along with the printf, that's going to imply that everything, if the if condition is true, should be executed below it until you start to unindent and start writing a different line of code altogether. So indentation in Python is important. So this is among the reasons we've emphasized axes like style, just how well styled your code is. And honestly, we've seen certainly in office hours, and you've seen in your own code, sort of a tendency sometimes to be a little lax when it comes to indentation, right? If you're one of those folks who likes to indent everything on the left-hand side of the window, yeah, it might compile and run, but it's not particularly readable by you or anyone else. Python actually addresses this by just requiring indentation when logically needed. So Python is going to force you to start indenting properly now if that's been perhaps a tendency otherwise. What else is missing? Well, we have no semicolon here, of course. It's print instead of printf. But otherwise, those seem to be the primary differences. What about something larger in Scratch? If an if-else block like this, you can perhaps guess what it's going to look like. In C, it looked like this, curly braces, semicolons, and so forth. In Python, it's going to now look like this. Almost the same, but indentation's important, the colons are important, and there's one other difference that's now again visible here, but we didn't call it out a second ago. What else is different in Python versus C for these conditionals? Yeah. Perfect. We don't have any parentheses around the condition, the Boolean expression itself. And why not? Well, it's just simpler to type. It's less to type. You can still use parentheses. And in fact, you might want to or need to if you want to like combine thoughts and do this and that or this or that. But by default, you no longer need or should have those parentheses. Just say what you mean. Lastly, with conditionals, we had something like this, an if, else statement. In C, it looked a little something like this. In Python, it's going to get really tighter now. It's just if, and this is the curiosity, elif x greater than y. So it's not else if. It's literally one keyword, elif. And the colons remain now on each of the 3 lines. But the indentation is important. And if we did want to do multiple things, we could just indent below each of these conditionals as well. All right, let me pause there first to see if there's any questions on these syntactic differences. Yeah? Between what and what? Good question. Is Python sensitive to spaces and where they go? Sometimes no, sometimes yes is the short answer. Stylistically, though, you should be practicing what we're preaching here, whereby you do have spaces to the left and right of binary operators that they're called. Something like less than or greater than is a binary operator because there's 2 operands to the left and to the right of them. And in fact, in Python, more so than the world of C, there's actually formal style conventions. Not only within CS50 have we had a style guide on the course's website, for instance, that just dictates how you should write your code so that it looks like everyone else's. In the Python community, they take this one step further, and there's an actual standard whereby you don't have to adhere to it. But generally speaking, in the real world, someone would reprimand you, would reject your code if you're trying to contribute it to another project if you don't adhere to these standards. So while you could be lax with some of this white space, do make things readable. And that's Python's theme, for the code to be as readable as possible. All right, so let's take a look at a couple of other constructs before transitioning to some actual code. This, of course, in Scratch was a loop, meowing forever. In C, the closest we could get was doing something while true, because true never changes. So it's sort of a simple way of just saying do this forever. In Python, it's pretty much the same thing, but a couple small differences here. The parentheses are gone. The colon is there. The indentation is there. No semicolon. And there's one other subtle difference. What do you see? True is capitalized just because. Both true and false are Boolean values in Python, but you got to start capitalizing them just because. All right, how about a loop like this, where you repeat something a finite number of times, like meowing 3 times? In C, we could do this a few different ways. There's this very mechanical way where you initialize a variable like I to 0. You then use a while loop and check if I is less than 3, the total number of times you want to meow. Then you print what you want to print. You increment I using this syntax or the longer, more verbose syntax with plus equals or whatnot, and then you do it again and again and again. In Python, you can do it functionally the same way. Same idea, slightly different syntax. You just don't bother saying what type of variable you want. Python will infer from the fact that there's a 0 right there. You don't need the parentheses. You do need the colon. You do need the indentation. You can't do the I++, but you can do this other technique, as we could have done in C as well. How else might we do this, though, too? Well, it turns out in C, we could do something like this, which, again, sort of cryptic at first glance, became perhaps more familiar, where you have an initialization, a conditional, and then an update that you do after each iteration. In Python, there isn't really an analog. There is no analog in Python where you have the parentheses and the multiple semicolons in the same line. Instead, there is a for loop, but it's meant to read a little more like English. For I in 0, 1, and 2. So we'll see in a bit, these square brackets represent an array, now to be called a list in Python. So lists in Python are more like linked lists than they are arrays. More on that soon. So this just means for I in the following list of 3 values. And on each iteration of this loop, Python automatically for you, it first sets I to 0, then it sets I to 1, then it sets I to 2. so that you effectively do things 3 times. But this doesn't necessarily scale as I've drawn it on the board. Suppose you took this at face value as the way you iterate some number of times in Python using a for loop. At what point does this approach perhaps get bad or bad design? Let me give folks just a moment to think. Yeah, I'm back. Sure, if you don't know how many times you want to loop or iterate, you can't really create a hard-coded list like that of 0, 1, 2. Other thoughts? Yeah, if you're iterating a large number of times, this list is going to get longer and longer, and you're just kind of stupidly going to be typing out like comma 3, comma 4, comma 5, comma dot, 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 comma 99, comma 100. I mean, your code would start to look atrocious eventually, so there is a better way. In Python, there is a function, or technically a type, called range that essentially magically gives you back a range of values from 0 on up to, but not through a value. So the effect of this line of code, for I in the following range, essentially hands you back a list of 3 values, thereby letting you do something 3 times. And if you want to do something 99 times instead, you, of course, just change the 3 to a 99. Question?
Is there a way to start the beginning point of that range at a number or an integer that's higher than 0, or is there never really a point to do so?
A really good question. Can you start counting at a higher number? So not 0, which is the implied default, but something larger than that? Yes. So it turns out the range function takes multiple arguments, not just 1, but maybe 2 or even 3, that allows you to customize this behavior. So you can customize where it begins. You can customize the increment. By default, it's 1. But if you want to do every 2 values for like evens or odds, you could do that as well, and a few other things. And before long, we'll take a look at some Python documentation that will become your authoritative source for answers like that. Like, what can this function do? Other questions on this thus far? Seeing none. So what else might we compare and contrast here? Well, in the world of C, recall that we had a whole bunch of built-in data types like these here, bool and char and double and float and so forth, string, which happened to come from the CS50 library, but the language C itself certainly understood the idea of strings because the \0, the support for %s and printf, that's all native, built into C, not a CS50 simplification. All we did and revealed as of a couple of weeks ago is that string, this data type, is just a synonym for, a type def for char star, which is part of the language natively. In Python now, this list actually gets a little shorter, at least for these common primitive data types. Still going to have bools, we're going to have floats and ints, and we're going to have strings, but we're going to call them strs. And this is not a CS50 thing from the library. Str, str, is in fact a data type in Python that's going to do a lot more than strings did for us automatically in C. Ints and floats, meanwhile, don't need the corresponding longs and doubles because, in fact, among the problems Python solves for us too, ints can get as big as you want. Integer overflow is no longer going to be an issue per week 1. The language solves that for us. Floating point imprecision, unfortunately, is still a problem that remains. But there are libraries, code that other people have written, as we briefly discussed in weeks past, that allow you to do scientific or financial computing using libraries that build on top of these data types as well. So there's other data types too in Python, which we'll see actually gives us a whole bunch of more power and capability. Things called ranges, like we just saw. Lists, like I called out verbally with the square brackets. Things called tuples for things like x, comma, y, or latitude, comma, longitude. Dictionaries, or dicts, which allow you to store keys and values, much like our hash tables from last time. And then sets in the mathematical sense, where they filter out duplicates for you, and you can just put a whole bunch of numbers, a whole bunch of words, or whatnot, and the language, via this data type, will filter out duplicates for you. Now, there's going to be a few functions we give you this week and beyond, training wheels that we're then going to very quickly take off, just because, as we'll see today, they just simplify the process of getting user input correctly without accidentally writing buggy code just when you're trying to get hello world or something similar to work. And we'll give you functions not as long as this list in C, but a subset of these. Get float, get int, and get string. That'll automate the process of getting user input in a way that's more resilient against potential bugs, but we'll see what those bugs might be. And the way we're going to do this is similar in spirit to C. Instead of doing include cs50.h like we did in C, you're going to now start saying import cs50. Python supports similar to C, libraries, but there aren't header files anymore. You just use the name of the library in Python. And if you want to import CS50's functions, you just say import CS50. Or if you want to be more precise and not just import the whole thing, which could be slow if you've got a really big library with a lot of functionality in it, you can be more precise and say from CS50 import get float. From CS50 import get int. From CS50 import get string. Or you can just separate them by commas and import 3 and only 3 things from a particular library like ours. But starting today and onward, we're going to start making much more heavy use of libraries, code that other people wrote, so that we're no longer reinventing the wheel. We're not making our own linked lists, our own trees, our own dictionaries. We're going to start standing on the shoulders of others so that you can get real work done, so to speak, faster by building your software on top of others' code as well. All right, so that's it for the syntactic tour of the language and the sort of core features. Soon we'll transition to application thereof. But let me pause here to see if there's any questions on syntax or primitives or otherwise. Or otherwise. No? Oh, yes, and back. Sorry, say it again. Why doesn't Python have what kind of operators? Sorry, someone coughed when you said something operators. The increment operator? I'd have to check the history, honestly. Python has tended to be a fairly minimalist language. And if you can do something one way, the community arguably has tended to not give you multiple ways to do the same thing syntactically. There's probably a better answer. And I'll see if I can dig in and post something online to follow up on that. All right, so before we transition to now writing some actual code, let me go ahead and consider exactly how we're going to write code. In the world of C, recall that it's generally been a 2-step process. We create a file called like hello.c, and then step 1, make hello. Step 2, /hello. Or if you think back to week 2, when we sort of peeled back the layer of what what make was doing, you could more verbosely type out the name of the actual compiler, Clang in our case, command line arguments like -o hello to specify what name you want to create. And then you can specify the file name. And then you can specify what libraries you want to link in. So that was a very verbose approach, but it was always a 2-step approach. And so even as you've been doing recent problem sets, odds are you've realized that anytime you want to make a change to your code or make a change to your code and try and test your code again, you're constantly doing those 2 steps. Moving forward in Python, it's going to become simpler, and it's going to be just this. The file name is going to change, but that might go without saying. It's going to be something like hello.py, py, instead of hello.c. And that's just a convention using a different file extension. But there's no compilation step per se. You jump right to the execution of your code. And so Python, it turns out, is the name not only of the language we're going to start using, it's also the name of a program on a Mac, a PC, assuming it's been pre-installed, that interprets the language for you. This is to say that Python is generally described as being interpreted, not compiled. And by that, I mean you get to skip, from the programmer's perspective, that compilation step. There is no manual step in the world of Python typically of writing your code and then compiling it to 0s and 1s and then running the 0s and 1s. Instead, these kind of 2 steps get collapsed into the illusion of one, whereby you instead are able to just run the code and let the computer figure out how to actually convert it to something the computer understands. And the way we do that is via this old process, input and output. But now, when you have source code, it's going to be passed into an interpreter, not a compiler. And the best analog of this is just to perhaps point out that in the human world, if you speak or don't speak multiple human languages, it can be a pretty slow process from going from one language to another. For instance, here are step-by-step instructions for finding someone in a phone book, unfortunately in Spanish. Unfortunately, if you don't speak or read Spanish, you could figure this out. You could run this algorithm, but you're going to have to do some Googling, or you're going to have to open up literal dictionary from Spanish to English and convert this. And the catch with translating any language, human or computer or otherwise, is that you're going to pay a price, typically some time. And so converting this in Spanish to this in English is just going to take you longer than if this were already in your native language. And that's going to be one of the subtleties with the world of Python. Yes, it's a feature that you can just run the code without having to bother compiling it manually first. But we might pay a price, and things might be a little slower. Now, there's ways to chip away at that, but we'll see an example thereof. In fact, let me transition now to just a couple of examples that demonstrate how Python is not only easier for many people to use, perhaps yourselves too, because it throws away a lot of the annoying syntax, it shortens the number of lines you have to write, and also it comes with so many darn libraries. You can just do so much more without having to write the code yourself. So as an example of this, let me switch over here to this image from problem set 4, which is the Weeks Bridge down by the Charles River here in Cambridge. And this is the original photo. Pretty clear, and it's even higher res if we looked at the original version of the photo. But there have been no filters a la Instagram applied to this photo. Recall for problem set 4, you had to implement a few filters, and among them might have been blur. And blur was probably among the more challenging of the ones because you had to iterate over all of the pixels. You had to take into account what's above, what's below, to the left, to the right. I mean, there was a lot of math and arithmetic. And if you ultimately got it, it was probably a great sense of satisfaction, but that was probably several hours later. In a language like Python, where there might be libraries that have been written by others on whose shoulders you can stand, we could perhaps do something like this. Let me go ahead and run a program or write a program called blur.py here. And in blur.py, in VS Code, let me just do this. Let me import from a library, not the CS50 library, but the pillow library, so to speak, a keyword called image and another one called image filter. Then let me go ahead and say, let me open the current version of this image, which is called bridge.bmp. So the before version of the image will be the result of calling image.open, quote unquote, bridge.bmp. And then let me create an after version. So you'll see before and after. After equals the before version dot filter of image filter. And there is, if I read the documentation, I'll see that there's something called a box blur that allows you to blur in box format, like one pixel above, below, left, and right. So I'll do 1 pixel there. And then after that's done, let me go ahead and save the file as something like out.bmp. That's it. Assuming this library works as described, I am opening the file in Python using line 3. And this is somewhat new syntax. In the world of Python, we're going to start making use of the dot operator more. Because in the world of Python, you have what's called object-oriented programming, or OOP as a term of art. And what this means is that you still have functions, you still have variables, but sometimes those functions are embedded inside of the variables, or more specifically, inside of the data types themselves. Think back to C. When you wanted to convert something to uppercase, there was a toUpper function that takes as input an argument that's a char. And you can pass in any char you want, and it will uppercase it for you and give you back a value. Well, you know what? If that's such a common paradigm where uppercasing chars is a useful thing, what the world of Python does is it embeds into the string data type, or char if you will, the ability just to uppercase any char by treating the char or the string as though it's a struct in C. Recall that structs encapsulate multiple types of values. In object-oriented programming, in a language like Python, you can encapsulate not just values, but also functionality. Functions can now be inside of structs. But we're not going to call them structs anymore. We're going to call them objects. But that's just a different vernacular. So what am I doing here? Inside of the image library, there's a function called open, and it takes an argument, the name of the file, to open. Once I have a variable called before, that is a struct, or technically an object, inside of which is now, because it was returned from this function, a function called filter that takes an argument. The argument here happens to be image.boxblur1, which itself is a function, but it just returns the filter to use. And then after.save does what you might think. It just saves the file. So instead of using fopen and fwrite, you just say .save. And that does all of that messy work for you. So it's just, what, 4 lines of code total? Let me go ahead and go down to my terminal window. Let me go ahead and show you with ls that at the moment, whoops, sorry, let me not bother showing that because I have other examples to come. I'm going to go ahead and do Python of blur.py. Nope, sorry, wrong place. I did need to make a command. There we go. OK, let me go ahead and type ls inside of my filter directory, which is among the sample code online today. There's only one file called bridge.b. Damn it. I'm trying to get these things ready at the same time. Let me rewind. Let me move this code into place. All right, I've gone ahead and moved this file, blur.py, into a folder called filter, inside of which there's another file called bridge.bmp, which we can confer with ls. Let me now go ahead and run Python, which is my interpreter and also the name of the language, and run Python on this file. So much like running the Spanish algorithm through Google Translate or something like that as input to get back the English output, this is going to translate the Python language to something this computer or this cloud-based environment understands, and then run the corresponding code top to bottom, left to right. I'm going to go ahead and enter. No error message is generally a good thing. If I type ls, you'll now see out.bmp. Let me go ahead and open that. And you know what? Just to make clear what's really happening, let me blur it even further. Let's make a box that's not just 1 pixel around, but 10. So let's make that change. And let me just go ahead and rerun it with Python of blur.py. I still have out.bmp. Let me go ahead and open out.bmp and show you first the before, which looks like this. That's the original. And now, crossing my fingers, 4 lines of code later, the result of blurring it as well. So the library is doing all of the same kind of legwork that you all did for the assignment, but it's encapsulated it all into a single library that you can then use instead. Those of you who might have been feeling more comfortable might have done a little something like this. Let me go ahead and open up one other file called edges.py. And in edges.py, I'm again going to import from the Pillow library the image keyword and the image filter. Then I'm going to go ahead and create a before image that's a result of calling image.open of the same thing, bridge.bmp. Then I'm going to go ahead and run a filter on that called image filter.findEdges, which is like a constant, if you will, defined inside of this library for us. And then I'm going to do after.save, quote unquote, out.bmp, using the same file name. I'm now going to run Python of edges.py. User error. We'll see what syntax error means soon. Let me go ahead and run the code now, edges.py. Let me now open that new file, out.pmp. And before we had this. And now, especially what will look familiar if you did the more comfortable version of pset4, we now get this after just 4 lines of code. So again, suggesting the power of using a language that's better optimized for the tool at hand. And at the risk of really making folks sad, let's go ahead and re-implement, if we could, problem set 5 real quickly here. Let me go ahead and open another version of this code wherein I have a C version just from problem set 5, wherein you implemented a spell checker loading 100,000 plus words into memory. And then you kept track of just how much time and memory it took. And that probably took a while, implementing all of those functions in dictionary.c. Let me instead now go into a new file called dictionary.py. And let me stipulate for the sake of discussion that we already wrote in advance speller.py, which corresponds to speller.c. You didn't write either of those. Recall for problem set 5, we gave you speller.c. Assume that we're going to give you speller.py. So the onus on us right now is only to implement dictionary.py. All right, so I'm going to go ahead and define a few functions. And we're going to see now the syntax for defining functions in Python. I want to go ahead and define first, a hash table, which was the very first thing you defined in dictionary.c. I'm going to go ahead then and say words gets this. Give me a dictionary, otherwise known as a hash table. All right, now let me define a function called check, which was the first function you might have implemented. Check is going to take a word. And you'll see in Python, the syntax is a little different. You don't specify the return type. You use the word def instead to define. You still specify the name of the function and any arguments there too, but you omit any mention of types, but you do use a colon and indent. So how do I check if a word is in my dictionary or in my hash table? Well, in Python, I can just say if word in words, go ahead and return true, else go ahead and return false. Done with the check function. All right, now I want to do like load. That was the heavy lift where you had to load the big file into memory. So let me define a function called load. It takes a string, the name of a file, to load. So I'll call that dictionary, just like in C, but no data type. Let me go ahead and open a file by using an open function in Python by opening that dictionary in read mode. So this is a little similar to fopen, a function in C you might recall. Then let me iterate over every line in the file. In Python, this is pretty pleasant. For line in file, colon, indent. How now do I get at the current word and then strip off the new line? Because in this file of words, the 140,000 words, there's word \n, word \n. All right? Well, let me go ahead and get a word from the current line, but strip off from the right end of the string the new line. which the rstrip function in Python does for me. Then let me go ahead and add to my dictionary or hash table that word, done. Let me go ahead and close the file for good measure. And then let me go ahead and return true because all was well. That's it for the load function in Python. How about the size function? This did not take any arguments. It just returns the size of the hash table or dictionary. In Python, I can do that by returning the length of the dictionary in question. And then lastly, gone from the world of Python is malloc and free. Memory is managed for you. So no matter what I do, there's nothing to unload. The computer will do that for me. So I give you in these functions problem set 5 in Python. So I'm sorry, we made you write it in C first. But the implication now is that what are you getting for free in a language like Python? Well, encapsulated in this one line of code is much of what you wrote for problem set 5, implementing your array for all of your letters of the alphabet or more, all of the linked lists that you implemented to create chains to store all of those words. All of that is happening. It's just someone else in the world wrote that code for you, and you can now use it by way of a dictionary. And actually, I can change this a little bit because add is technically not the right function to use here. I'm actually treating the dictionary as something simpler, a set. So I'm going to make one tweak. Set, recall, was another data type in Python. But set just allows it to handle duplicates, and it allows me to just throw things into it by literally using a function as simple as add. And I'm going to make one other tweak here. Because when I'm checking a word, it's possible it might be given to me in uppercase or capitalized. It's not going to necessarily come in the same lowercase format that my dictionary did. I can force every word to lowercase by using word.lower. And I don't have to do it character for character. I can do the whole darn string at once by just saying word.lower. All right, let me